Hey guys, welcome back. Okay, so now we need to look at what happens when we have a collision in our hash map. So suppose Sally, we generate a hash and we get some number. It's equal to the same hash for a different key. Well, that's going to be a problem because every time we do this, right? Every time we call this get function, if we call it with Sally, we should always get the value associated with Sally. We shouldn't ever get the value associated with some other key, right? So just to forcibly do this, let's actually, what we can do is we can return the same hash for every item. So for Sally, we're going to return a hash of 0. The same thing for YLLAS, we're going to return a hash of 0, and the same thing for Joey. Now, if we try this, it'll work for, let's see here, we put in Sally. It won't work for Sally because now Joey, if you look at our hash map class, right, what's going to happen is every time we try to put an item in, it's always going to be the hash is always going to be 0. So we're always going to be putting it in the 0th index of our values array. And so in this case, the last item we put in is Joey. And so if we put in a key of Sally, we're going to be getting the value for Joey, which is completely incorrect. So the way we can handle this is by having an array list for each item inside of our values list. So the way we can do this is as follows. Where are we initializing? So we have our values right here, right? And what we're going to do is we're going to create an array list that's going to be of type V. And then for each item inside of our array list, we're going to have, actually let me just write it out, I think it'll make more sense. It's a little difficult to think about. So ignore that weird syntax as before. And now what we're doing is, okay, so actually I'll just do it like this. So we have a block, we have a bunch of blocks of memory, right? And inside each of these blocks of memory, we have an array list. That's all we're doing. So inside each of these blocks of memory, we have an array list. Okay, well, what is an array list? Remember that an array list, it just contains, so for example, array list at index 0, well, all it is it's some more blocks of memory. And inside each of these blocks of memory, we're going to be storing a value. And that value, its type corresponds to this type V, and it's just going to be the value we're putting in inside of our put function. So it's this is what our memory looks like. Now what we're going to do is first we're going to compute the hash, right? So int index is equal to get hash at key. Right? Now what we're going to do is we're going to do values at index, right? And then this is going to give us an array list of values is equal to, let's see here. So values. And okay, so we're getting a compiler error because we have to rename this from values because we have this values up here. Let's just call it items. Okay, so now what we're going to do is we're going to go through our items list. And okay, so at this point, now what we need to do is we need some way of determining whether a particular value inside of this list has the same key as this value, as the key we're passing in here. If the size is not equal to 0, if there are multiple items within this array list, then it means that we at some point had a collision, or we're about to have a collision, right? So what we need to do is we need some other kind of class. We need a holder class. So we can do it like this. This holder class, it's just going to have a, actually, do we still have it in our main class? In our main? We do. Let's just copy this guy over. So now we have this holder class. Now, okay, at this point, I think the best thing to do is to show you guys a graphic. So let's go over here and examine what we need to do. We have our key value entries, right? So we have a key, we have a value, and we're putting it inside of this hash function. Now this is our list. This is our memory. Inside each of these blocks of memory, we're storing a particular key and value. The problem is sometimes whenever we hash a particular key, we might get the same hash as another key. In that case, two things are being stored at one memory location, and that's not going to work. So what we're going to do is we're going to create a bucket. In our case, the bucket is the same thing as this holder class right here. This is the same thing as a bucket. And what it's going to do, the bucket is the same thing as each array list. The bucket is the same thing as each array list because what it's going to do is it's going to contain a list of keys and values, where each key and value we're storing inside of this holder class. Okay, so now what we're going to do is first we're going to generate a hash, right? We're going to generate a hash and it's going to give us an index. Then we're going to look inside of our bucket. Every bucket is going to have at least one item. If the bucket has more than one item, then what we're going to do is we're going to go through every single item in our bucket and compare the key with the key that's given inside of here. If the key that we're providing is the same thing as a key as one of these keys in the bucket, then all we're going to do is we're just going to update the value that corresponds to that key. Okay, so let's say that we have key 2. Well, key 2 might have this value, right? We're going to hash it, and that's going to give us this index. Now what we're going to do is we're going to loop through every item inside of our bucket. So given key 2, we find that, okay, it's this first item inside of our bucket. It's this first item, so then we're just going to update it with this new value. Alright, fair enough. Let's just go through each of our items inside of our bucket. Let me rename this to bucket so it's a little more clear. We're going to loop through it, and then we're going to do bucket.get at I, and when we do this, we're going to be given, let's see here, we need to change this a little bit. Inside of our bucket, we're going to store holder objects, and we need to actually put this at the top of our class up here. Let's see here, yeah, this guy, holder. And okay, so the holder, it's going to have type key and value v that correspond all the way up here. Do we need to rename these guys? What is this error? Oh yeah, this could be. Alright, we'll ignore it for now. Alrighty, so where were we? So when we do bucket.getI, well, what are we going to get? We're going to, oh man, we have to change this actually real quick. Holder, kv, okay, and now we need to change this guy to Oracle, okay, kv, and now finally, yeah, there we go. Now we're going to be getting holder, kv, item. So this line, it's referring to this item right here. So this is one item inside of our bucket. So now that we have that bucket, what we're going to do is we're going to get its key, and if it equals the key that we want to put, then we found the item we want to update. Then we do item.value is equal to value. But suppose we go through our entire bucket and we don't find the key that matches with the one we want, the one that we're passing into this put function. If that happens, then we need to add that item to the end of our bucket. So what we can do is we need a boolean. Boolean did find item in bucket, and it's going to be initialized to false. And if we found it, then we say did find bucket is equal to true, and then we're just going to break. But if we didn't find the item in our bucket, if we went through every entry in the bucket and we got to the last one and we still didn't find the key that corresponded to the key we were passing in, then what we're going to do is we're just going to do bucket.add, and we're going to create a new holder. And now, don't need that. We're going to do new holder, okay, and its key is going to be equal to this guy, and its value is going to be equal to that guy, semicolon, and we're done. Now we just have to do the same thing with our get function. So what we're going to do is, for now, I'm just going to copy this code just because we can be a little lazy sometimes. So we're going to fetch we're going to get the hash, right? We're going to compute the hash, which will give us an index. Given an index, now we need to loop through every item inside of our bucket until we find the one we want. So now, if item.value, then all we do is we just return item.value. Otherwise, if we never found anything, we just return null. Okay, so is there a way we can make this a little more succinct, a little more reusable? Yeah, there is. We can create a function called holder, and what it's going to do is it's going to get an item given a key. And let's key, actually we can just do this. Or actually, no, an even better approach. We've already done this right here. All we need to modify is the stuff we're doing up here. So we can get rid of all of these guys. And what we can do we want to return a holder, right? We're going to make this function private. Then we're going to make another function, get holder, and it's going to return the actual value. So it's going to return this value given a key. Let's see here, get given a key, and then holder key. Holder is equal to get holder given a key, right? And now if holder is not equal to null, then we're going to, why are we getting compiler error here? It's not, oh man, it's the wrong type of key. K key, there we go. Then we're just going to do return holder dot value. Otherwise, we're just going to return null. Okay, so now all we need to do up here is holder v, and then item bucket is equal to key, right? So now, if the item in bucket is not equal to null, then we're going to update its value. Okay, so let me put that guy down here, and now we do item in bucket dot value is equal to value. All right, so now we have a little bit of a problem because we refactored the code a bit, right? So now we don't have this bucket variable. So the best approach is to create another function. Notice what we're doing. We're creating lots of little functions and we're trying to avoid copy pasting as much as possible. This is useful because, you know, if we change any part of these functions, if we change the get function, we only have to change it once down here. Where's our get function? For example, if we change this get holder function, we only have to change it once. We don't have to change it here and there and there. And it makes our code more compact. Notice we're doing all of this crazy stuff. We're doing all of this functionality in less than 80 lines. This is incredible. So get bucket. So now we want to get the bucket, right? So now all we do is we take this functionality up here and we just return. So oops, given a K key, and let's see here, it's not being used, and now it's very simple. Array list holder K key bucket is equal to get bucket key. And okay, so yeah, so we just want to return item right here. Okay, good. And now let's see here, we might run into the issue when the bucket is null. So when values and index is equal to null. So then the easiest way to deal with this is just to go through our entire list and make sure that each item inside of this list of memory, each item it's going to have a bucket. So we just need to make sure that each bucket is initialized. It might not have any keys and values, but we just want to make sure that it's initialized. So then what we can do is for actually that's not quite what we want to do. We want to do this. Then values at I is equal to new array list. And that's it. So that's just going to make sure that we have a value inside of each bucket, or inside of each index. So then we're going to do get bucket at key add, and that's it. Very succinct code. Alright, so there's potential for bugs in here, but let's test this out. Okay, so remember, all the way up here, each of these items, they're being given the same hash, right? And when we first ran this, we were getting a value of 40 for Sally, when in reality we should have been getting a value of 100. So let's run, and let's hope nothing crashes. Okay, so we are getting a crash. That's unfortunate. So, okay, this could be difficult to deal with. Okay, so the easiest way to deal with this error is just to do this. This isn't the best approach, but it'll work for our cases. We're just going to, let's see here, make a new array list of new array list like that. Okay, so now we've just created a bunch of array lists. We've created an array of array lists in essence. And okay, so now we should get a value of 100 for Sally. That'll work just fine. And now this person should be 23 and then 40. Okay, so so what's happening is now that we've done this, we're in essence this is our original problem where we were using array list to search through a bunch of items instead of a hash map. So when we use a hash map, at worst case, we're going to be using our original method of looping through every item inside of an array list. That's our worst case scenario. Our best case scenario is that each bucket contains only one item. Each bucket contains only one item. If each bucket contains only one item, then it's very simple. We can hash it, and then every hash is just going to go into one bucket, and then we can fetch that value instantaneously. The larger we make our list, the larger we make this list, the greater the odds that we're going to have this scenario, this best case scenario where we can just fetch it instantly. And that's because we're moduloing it by a larger number, so we're going to have fewer collisions. Fewer collisions mean that we're going to have fewer items being added to our bucket. The problem with that is, if we make it too large, then we're going to be consuming too much memory that we might not actually be using. So, there are all these considerations to take into account. Also, actually, one more point. If you make this number prime, if we were to make this number prime, then the odds of getting a collision are even smaller, because any number modulo a prime number, if you think about that, you're just going to have fewer collisions. Okay, so this was a very thorough introduction to hash maps and how they work inside, like how the inner workings of hash maps. These are very useful. You're going to find yourself using them quite a lot, and it's nice to know how they work inside, just because generally when you're at an interview, for example, they'll ask you about the most efficient ways to do something, and 75% of the time the answer is just use a hash map, and that's because these guys are very, very powerful. Anyways, in the next few videos we're going to be looking at 2 more data structures that are also pretty useful, and then we'll be wrapping up this section. Alright, I'll see you guys then.